So today's lesson I called Types of Forces. And we're going to build on what we did last day with our knowledge of free body diagrams and Newton's laws. The first one I'm starting out with, though, I already snuck in. The first type of force. Now, I need to do a letting you know honest truth. This whole lesson is a lie and it's garbage. I'm going to give you a bunch of types of forces. Actually, any physicist will tell you there's only 4 forces. Jake, you with me? Because you're looking down at something the whole time there. You hear? Any physicist will tell you there's only 4 forces in the universe. Gravity, gravitational force. Electromagnetic force, which explains how magnets work and why static cling can attract other things. That's a force. Then there's what's called the strong nuclear force and the weak nuclear force. And those go on inside the nucleus on the atomic level. Those are actually the only 4 forces in the universe. But when you zoom out, it's easier to make up forces that you observe, even though they're actually outcomes, Mark, of those 4 interacting. We're not going to try and break everything down into the 4 fundamental forces. We're going to have all sorts of technically mythical forces that don't really exist, but they're going to let us calculate, so we're going to use them. All right. The first one I already snuck in, gravitational force. The symbol that I use for gravity is capital F with a little g, gravitational force, Fg. And who remembers last day what the equation was for the force of gravity? Force equals what times what, first of all? Ma, but what symbol did we use for A when it came to gravity? Okay, so we said this. Fg equals mg. In fact, I think I said to you that very frequently on a free body diagram, I won't even write Fg, I'll just write the equation mg, because to me those are so interchangeable. Only true as long as you're close to the Earth, though, because as you go further and further into outer space, that negative 9.8 does get smaller and smaller and smaller. Direction. Hey, which way does gravity act? I saw about 5 kids go like that. The only problem with saying down is in Australia, they would be pointing this way relative to them. So I'm going to be a little fussier. I'm going to say direction towards the what? Center of the gravitational body. Planet, moon, star, whatever. Towards the center of the gravitational body. The body that's producing a lot of gravity. Gravity, by the way, is out of the 4 fundamental forces, it's by far the weakest. You think it's the strongest because it's the one that dominates your life. But think about how big is the Earth? Huge, yet with a tiny magnet, I can pick up a paper clip with that tiny magnet, completely overcoming the force of gravity on that paper clip that huge Earth is putting out. Gravity is weaker than weak. It's like 10 to the 27th times weaker than all the other forces. Okay? But Taylor snuck it in last day. The one we're going to spend a lot of time talking about today is something called the normal force. Now, this is a reactive force. It's the result of Newton's 3rd law. What was Newton's 3rd law? Forces come because it's a reactive law, it's only as big as it needs to be. It will never be bigger than the pair that caused it in the first place. What is the normal force? It's the force that prevents us from falling into the ground. So, what does a scale measure? You know what? I'm going to bold and underline that. This is going to lead us into what we call elevator questions. Here's a classic elevator question. Okay, get your attention span back here. Classic elevator question says this. A 72-kilogram man stands on a Newton scale in an elevator. What does the scale read if the elevator is accelerating upwards at 3.2 meters per second squared? Brad, what am I asking you to find here? What does the read? Oh, sorry. What does the? You're right. Say it again. the word after scale as well. What does the scale read? Okay, ready? Scene 1, act 1, take 2. Brad, what's this question you asked me to find?
What does the scale read?
Except it's not. What am I really asking you to find? The normal force. In our free body diagram, the normal force. Okay? And this may sound really, really obvious, but this is going to open up some very, 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 very nice questions.